In this video, we're going to talk about the area rule, but before doing so, we need to discuss the convention used to labeling the sides and angles of a triangle. And so starting with the sides, we use lowercase letters to show that we are talking about the side of a triangle. And so let's label the sides here. We're going to label A, B, and C. And labeling the angles, we always label the angles opposite the corresponding side, and they're always written in uppercase letters. And so angle A will be opposite side A. And so we'll have angle A here. Angle B will be opposite side B, so up here. And C will be opposite side C. So moving on to the area rule, the area of a triangle is equal to half A times B times sine of our angle C. And you can see here that the convention used to labeling the angles and sides of a triangle is used in this formula. And so what we're going to do is we're going to try to derive this formula and then move on to a couple of examples. And so when we want to derive this formula, we're going to start off with the area of our triangle equals to half the base times the height. So we're going to start with this fact, and we're going to first consider the acute triangle case. So we have an acute triangle here, and we're going to label in its height. So let's label in its height, which will be this distance here in red. And we're going to label it as H. And so notice that we have a right triangle here. And what we're going to do is we're going to consider sine of our angle C. And so let's write this down. Sine of C is equal to, or opposite over our hypotenuse side using our SOHCAHTOA mnemonic. And our opposite side is going to be our height H. And our hypotenuse is our side A of our triangle. And so what we're going to do is we're going to solve for our height H, and we get H is equal to A times sine of our angle C. Now we're going to consider the half base times height formula. So we have the area of our triangle is equal to half the base of our triangle, and our base is going to be the side B times our height. And our height of our triangle is H. And we found that H is equal to A times sine C. So let's sub in this value and we get A times sine C. And notice here, if we swap the B and A values, we get the area rule. And so now we have successfully proven the area rule for an acute triangle. And so what we're going to do now is derive the area rule for obtuse triangles. Now we are going to derive the area rule for the obtuse triangle case. So considering this obtuse triangle here, and we have a vertical line starting from the base of the triangle to the top, which represents its height, labeled as H. And we're going to label in one more angle, which is going to be this angle here, and that is 180 degrees take C, as we have a straight line here, and this angle is C. And so what we're going to do is consider this right triangle here, and more specifically, the sine of this angle. And so we have sine of 180 degrees take C, which equals opposite over hypotenuse using our SOHCAHTOA mnemonic. And we have our opposite side is our height H of our triangle, and our hypotenuse is our side A. And so if we solve for H, we get H equals A times sine of our angle 180 degrees take C. And we can actually simplify this expression a bit more, where sine of 180 take C can simplify, but we're going to show this using the unit circle. So here we have a unit circle, and we're going to label in an angle C. So suppose this angle is C. And we're going to draw in another angle, 180 degrees take C. And so this angle here is 180 degrees take C. And if that's the case, then this angle must be C also. And remember, when reading sine of an angle on the unit circle, it is always the value you read off the y-axis. And so if we want to find sine of C, this will be the value we read off the y-axis, which is this value here. And if we want to find sine of our angle 180 degrees take C, then we find that it will be this y value here. And notice that we have the same y value for our angle of 180 degrees take C and our angle C. So this concludes that sine of our angle C is in fact equal to sine of 180 degrees take C. And so we can use this fact here, where we can rewrite our expression as h equals a times sine of C. And now we can use our half base times height formula for the area of a triangle. So the area of a triangle equals half the base times the height. And so considering our triangle here, we have half the base, which is going to be our side B, times our height. And we've written an expression for our height as A times sine C. And if we swap our A and B values around, we get the area rule for our obtuse triangle case. And so that concludes our derivations, and we're going to now move on to some examples. To begin our examples, we're going to start with this triangle here, where we want to find the area. And rewriting the area rule, we have the area of a triangle is equal to half A, B, sine C. And so for this triangle here, let's label our sides and angles using our triangle convention. So let's label this side A and this side here B that we're given. And by the convention used to label a triangle, this angle in between will be angle C, as side C will be here. And so now, if we want to find the area of this given triangle, we can just sub in the values into our area rule. So we get the area of our triangle equals half A, which is going to be 5, times B, which is 6, times sine of our angle C, which is sine of 40 degrees. And by solving on our calculator, we get our area for this particular triangle is 9.64 meters squared. And so now let's move on to this example here, where we want to find the area of this triangle. And let's label in the sides. So we've got two sides here, so we're going to label them sides A and B to follow the area rule. And angle C is going to be this angle here between sides A and B. And notice we do not have angle C, but we have two other angles of the triangle. And remember that the sum of the angles in a triangle always add up to 180 degrees, so we can solve to find our angle C. So we have 180 degrees is equal to 40 plus 30 plus our angle C. And solving for C, we have C having an angle of 110 degrees. And so this angle here is 110 degrees. And now we can use our area rule to solve for the area of this triangle. So we have the area equals half A, which is 6, B, which is 8, times sine of our angle C, and our angle is 110 degrees. And solving this on our calculator, we get our area to be 22.6 centimeters squared. And now let's rub this out to leave room for one more example. Now for this example, we want to solve for one of the sides x, and we have given the area of the triangle, one of the angles, and one of the sides. And so here we are now solving for one of the sides using the area rule. And so let's label the sides and angles. So we're going to label this as side A, we'll label this as side B, and what angle C is going to be 135 degrees, and we're given the area equal to 45 meters squared. And so notice here we are solving for our side B. And so when we have the area rule, we're going to rearrange it to solve for B. So we have half AB times sine of C, and we're going to start off by timesing both sides of the equation by 2, and we get 2A equals A times B times sine C. And now to isolate B, we're going to divide both sides of the equation by A sine C. So we get B equals to 2 times the area over A times sine of our angle C. And so now plugging in the values into our formula, we get B is just x, the variable that we're solving for, equals 2 times the area of our triangle, which is 45, divided by A, which is 15, times sine of our angle C, which is going to be sine of 135 degrees. And so solving on your calculator, we get a value for x being 8.49 meters. And so that concludes this video, and in the next video we're going to discuss the sine rule.